Hey everyone, after this lesson, you'll be able to analyze conditional statements. And this is a concept we're going to need before we write proofs in this upcoming chapter. So remember, you can always pause and rewind the video if you need to slow things down and check over your notes. Okay, so first of all, what is a conditional statement? We're going to start off with just some of this key vocab here. A conditional statement is just a logical statement. So it's a logical statement with the following two parts. A hypothesis and a conclusion. And we're going to define what those things are. A conditional statement is usually written as an if-then format. So it's usually written with the if something, then something format. Okay? A hypothesis is simply the proposition. Okay, it's just the proposition. And you've all heard of this word before. So essentially, when we're writing an if-then statement, the hypothesis is the part that follows the if. So I'm going to put a capital H there that represents hypothesis. So it's the part that follows after, or the phrase that contains the word if. Okay? So then a conclusion is just the result. And if you could guess, it's the part that follows after the then. So I'm going to put a capital C in there to represent that the conclusion comes after the then. So it's the part that follows after or contains the phrase or the part of the phrase that says then. Okay, so a couple more vocab words. We're going to be talking about what a negation of a statement is, or to negate a statement. So this is simply just the opposite of the original statement. That's it. So it's the opposite of the original statement. So just a quick example of this. I could say, example, the ball is red. Okay, the ball is red. Well, if I wanted to write a negation or to negate this statement, the negation, which is the opposite, would simply be the ball is not red. That's it. Okay, an equivalent statement, which is pretty self-explanatory. An equivalent statement is just when two statements are both true or are both false. And we'll actually be going back to this slide to give you an example of two statements that would be equivalent. So we'll do that in a bit. All right, we're almost done with writing out some vocab, and then we'll see some examples. So let's write down what the converse statement is. So a converse is simply when you take that original conditional statement, the if-then statement, and you just switch the hypothesis and the conclusion. So you switch them. And we'll see an example of this coming up shortly. So the inverse of a statement is actually when you just negate. So remember, that means just make the opposite. So use the word not. You negate both the hypothesis and conclusion. And again, we'll see an example in a moment. All right, a contrapositive statement. This is when you first write the converse. So you write the converse, and then you take the inverse of that. So a contrapositive is when you write the converse, and then we negate. The hypothesis and conclusion. All right, so let's get ready to see an example here of all of these terms in action. Example, all birds have feathers. Okay, so first let's identify what the hypothesis and conclusion are here. I would say that, speaking of the birds, saying all birds, that would be my hypothesis. Then the fact that the birds have feathers, I would call that my conclusion. So let's go ahead and write a conditional, which is just an if-then statement. And let's make sure we apply the hypothesis coming after the if and the conclusion coming after the then. So I would simply say, if an animal is a bird, so let me color code this. If an animal is a bird. So see how that comes after the if? That's the hypothesis. Here's the conclusion. If an animal is a bird, then it has feathers. Cool. That's a conditional. If an animal is a bird, then it has feathers. The converse of that, remember, we're just switching the hypothesis and conclusion. So now my statement is going to say, if an animal has feathers, if an animal has feathers, that's now my new hypothesis. My new conclusion is, then it is a bird. All right, let's go ahead and do the inverse. Now remember, the inverse is when you simply take that conditional statement and we're going to negate that. So I'm going to go ahead and say, if an animal is not, so this is where you negate it, a bird, then it does not have feathers. So see, we're just taking the opposite or the negative. And that's the inverse statement. Now the contrapositive, we're going to do the same thing, but we're going to be using the converse. So we're going to be using the converse. So I'm going to go ahead and say, if an animal does not have feathers, then it is not a bird. It is not a bird. Sorry about my handwriting. It's a little hard to write on this tablet. So that's an example of all these different types of statements, and you'll be seeing this over and over again. So I'm going to see if you can figure a couple examples out on your own. So just pause the video, see if you can figure it out by yourself, and then you'll check the answers. So here's another example. The statement is, guitar players are musicians. Again, identifying that my hypothesis here is you are a guitar player. The conclusion being, then you're a musician. All right, so go ahead and take a minute to think about what the conditional statement would look like, what the converse statement would look like, and what the inverse and contrapositive would look like. Pause this, try it on your own. So here's the solutions. The conditional, if you are a guitar player, then you are a musician. The converse, if you are a musician, then you are a guitar player. The inverse, if you are not a guitar player, then you are not a musician. Contrapositive, if you're not a musician, then you are not a guitar player. So let's talk about when these statements are true and when they are false. So looking at the very first statement, the conditional says, if you're a guitar player, then you're a musician. I would definitely say that's probably true. If you know how to play guitar, then you're probably a musician. But let's look at the converse. Do you think that if you're a musician, then that means that you definitely play guitar? No, I mean, you probably could play other instruments. You might be a piano player, right, or a drummer. So I would say that's false. That's not always true. Let's look at the inverse statement. If you're not a guitar player, then you're not a musician. What do you think? Is that true? Always? Or could that be false? I would say it's false because I'm not a guitar player, but I might call myself a musician because I know how to play violin. Okay, now the contrapositive, if you are not a musician, then you are not a guitar player. Well, this one's a little bit tricky. I could argue if you're not a musician, then you're probably not a guitar player, like professionally, right? So I could argue maybe that would be a true statement. But some of you might say, well, I just play around with the guitar, but I don't call myself a musician. But for this sake, we're going to say it's true. If you're not a musician, then you're probably not a guitar player. All right. So looking back at that example I told you we would go back to before about equivalent statements, and you'll find that on page 2 of your slides. So I'm going to go back to that right now. When we're looking at equivalent statements, if you look at the guitar player example, you could identify which two statements are equivalent and which two statements would not be, right? So you look at the ones that are both true and the ones that are both false. So in that example of the guitar player, notice that the conditional statement we said was true, and the contrapositive statement we said was also true. So I would say that those two statements in that example, in that specific example, the conditional and the contrapositive, we would call those equivalent statements. Just to give you an idea of that. And we'll talk more about this in class. All right, so let's finish off these notes with just one more example for you to try. Here's a math definition, right? An example I want you to think about. All 90-degree angles are right angles. So here's my hypothesis. 90-degree angles is what we're talking about. And the result that means they're right angles, my conclusion. Let's see if you can write the conditional, converse, inverse, and contrapositive. So pause the video, see if you can do that on your own. And here are the results. So I'll let you take a look at this and notice all of these statements, especially the conditional and the converse together, they're both true. You know that if an angle has a measure of 90, then it's a right angle. And if an angle is a right angle, then we say that it has a measure of 90. So those are all true. And in fact, when both a conditional and a converse are true, we have a special name for that. And this is going to be the last slide and the last thing that we talk about for today. A biconditional is a statement when both the converse and the conditional are true, okay? And this type of statement is normally written with the following phrase. You'll see this. If and only if. If and only if. And normally there will be some hypothesis and some conclusion, but we can invert those and switch them because it's biconditionally true. So you'll see this phrase, if and only if, and that's for biconditionals. All right, guys. Any valid definition in math, especially, can be written as a biconditional. And we're going to start class off tomorrow by defining perpendicular lines, and we're going to write that as a biconditional. I hope you enjoyed the video. I'll see you tomorrow.